Hi, everyone. The next lesson that we are moving into requires really strong fraction skills. You have to really be able to manipulate fractions pretty smoothly to understand what's going on, and mostly fractions with variables in them. So I thought it would be important today to take some time and just refresh ourselves on fraction skills. How do we add, subtract, multiply, divide with fractions? So I'm going to start out with addition. And again, some of you may already know this or should already know this, but it never hurts to kind of refresh ourselves. So let's suppose I wanted to add together 3/5 plus 2/3. Okay. To add fractions together, I need a common denominator. So I need to be thinking about, what do 5 and 3 have in common? What can I multiply them both into? And I could turn them both into 15. So I can multiply on this side by 5 and on this side by 3. And notice that if I multiply by 5 over 5 or 3 over 3, I'm really multiplying by 1, right? And so then here I end up with 9 over 15. And here I end up with 10 over 15. And then for my final answer, I would just say 19 over 15. Now, one of the more common ones you're going to see is taking a fraction, like let's say 1/4, and adding like a whole number 1 to it. And these ones I think can be done even quicker, because as far as your common denominator goes, we just need to take this 1 and write it as something over 4. And you've seen me do this before when we're talking about 2 pi and things like that. So how can I write 1 as something over 4? Well, I know 1 can be written as anything over itself. So I'm just going to make it 4 over 4. And then 1 over 4 plus 4 over 4 makes 5 over 4. Okay. And obviously I chose 2 addition examples here, but you could do the same thing with subtraction as well. So now let's remind ourselves how to multiply with fractions. And I think sometimes we think that multiplying with fractions is more complicated than it really is. When you're multiplying with fractions, so let's say 7 over 3 times 4 over 9. All we're doing is multiplying straight across. So top by top, bottom by bottom. And so we end up with 28 over 27. And then, of course, in your final result, if you can do any sort of simplifying, go ahead and do it. In this case, I can't. Okay? So now what happens if I want to do, like, for example, 4/5 times 3, and that 3 is just a whole number. Shortcut here is you're really just multiplying by the top. So this just becomes 12 over 5. Now I'm going to show you why in just a minute. Okay, so I could just write that as 12 over 5. The reason for that is that 3 could really be written as 3 over 1, and then you're multiplying 4 times 3 and 5 times 1. But when you're just multiplying by a whole number, you're really just working with the numerator. The denominator stays the same. So now let's talk dividing with fractions. So let's suppose I wanted to do 7/8 divided by 4/5. Okay, we have to remember that multiplication and division are opposites each other. So dividing is really the same thing as multiplying by a reciprocal. So I could really take this thing and rewrite it as 7/8 times 5 over 4. And then I'm going to do it just like we did before. So top times top is 35. Bottom times bottom is 32. And so final answer there is just 35 over 32. And of course, if that could be reduced, we would do it. So now, what about a situation where I'm doing a fraction where I have, I don't know, 3/2, and I'm just dividing by a single whole number? Let's say I want to divide by 4. Okay. Again, we've talked about this shortcut quite a bit in class, but a fraction is already a division problem. So you can just incorporate this 4 into the denominator and make this 3 over 8. I want to show you, though, why that's true. So if I think about it the same way I thought about the top one, I said I'm going to multiply by a reciprocal, right? So I'm going to do 3 over 2 multiplied by the reciprocal of 4. So if 4 is really 4 over 1, the reciprocal would be 1 over 4. And then when I multiply straight across, I get the same thing I got a second ago. I get 3 over 8. Okay. All right, so what about if I switch the positions on those two things? And let me see if I can get us some more room here. Slide this up just a little bit. What if I have 4 divided by 3/2? Well, if I, again, think about it as multiplying by a reciprocal, this is really 4 times 2/3. And remember that 4 can be written as 4/1. So 4 times 2 is 8, and 1 times 3 is 3. You'll notice that I got the reciprocal of what I got up above because I took the original fraction or the original division and just did it in the opposite order. Okay, so that's how we divide with fractions. Okay, one more piece that we kind of need to address, and there's really 2 parts to this. So first of all, if you end up, and I guess I'm working more with variables at this point. If you have something like x to the 5th divided by x to the 3rd, let's see if we remember how to reduce those. Remember that x to the 5th is really like x times x times x times x times x. X to the 3rd is really x times x times x. And then if we start canceling things out, I'm going to be left with 2 x's, and we would call that x squared. So really your rule here is that you're subtracting exponents. If you subtract exponents and you have more left on the bottom than you do on the top, then you would have like a 1 over something. You would leave it on the bottom. Okay? So that's the first thing I want to remind you about powers. The second thing is, how do you raise a fraction to a power? So I'll go back into the land of actual numbers here. So if I have 2/3 and I want to square that, I'm really just squaring the top and squaring the bottom. So 2 squared is 4, 3 squared is 9, and so that would be 2/3 squared is 4/9. All right, I think that's everything I needed to show you to get you through some of the fraction practice stuff that you're going to work on today. And some of this you're going to look at and be like, why on earth is she making me do all of this? But I promise you, when we get into our lesson that we're going to jump into next week, you're going to feel so much better about it if you get really good at the stuff in this packet. Okay? All right, have a great day.